Okay, so good day everyone. This will be the discussion for Extra 4B, which is the double indicator titrations in CHEM 32.1. So sa double indicator titrations, it takes advantage of the property of indicator to change color in different points in neutralization reaction. So by double indicator, it means we have to observe two endpoints to determine the proportions of the component. So in Chem 32.1, we'll focus on the carbonate mixtures. So ang carbonate mixtures natin can be in several proportions of the NaOH sodium carbonate or sodium carbonate and sodium bicarbonate and an individual component of this mixture. Okay? So it can either be done via single flask method or double flask method. The sa single flask method, ibig sabihin lang nito is we will have to titrate in a single flask. So suppose we have one flask using indicator 1, tapos na-reach na yung endpoint ni indicator 1. By then, we will add indicator 2 until we reach the endpoint of indicator 2. Okay? Then sa double flask method naman, we make use of two separate flasks. So yung flask 1, dito natin ilalagay si indicator 1. Then si flask 2, dyan natin ilalagay si indicator 2. Then we will have to compare the volume used during the titration. Okay? So in double indicator titration, we'll be using two indicators in the form of phenolphthalein and bromcrystal green. Okay, so yung color transition natin for phenolphthalein is from bright pink to faint pink. Okay, so bakit tayo mag-start sa pink? Because ang ating color or ang ating pH transition is from alkali to neutral. Okay, as you can recall from your exer 4A, pag alkali or pag basic, color pink ang ating phenolphthalein. Okay? So, since ang ating composition is composed of carbonate mixture, it has NaOH, sodium bicarbonate, and sodium hydroxide. So, ito yung mga basic components natin. So, basically, basic ang laman ng ating solutions. Okay? Then we have the bromcrystal green or the BCG. The color transition of it will be from blue to yellow. And it will only occur at pH range 5.4 to 3.8. And the endpoint for bromcrystal green is yellow-green. So as you can recall from the laboratory, it is more yellow than green na yellow-green. Okay? So this is the example of the endpoint for the bromcrystal green. So nagkakaroon tayo ng color change at this pH range. Yan dito. So dito natin nakikita yung yellow-green kasi nagkakaroon ng nag-overlapping of colors na yung yellow tsaka blue. Okay? So yung ating color here is more yellow than green. Okay? Then as we titrate the carbonate mixture, the solution containing the carbonate ion, when titrated with an acid, requires equal amounts of acids for the first and the second reaction. So yung ating carbonate ion, so yung carbonate natin, more likely galing yan sa ating sodium carbonate. Okay? So yung sodium carbonate, when dissolved in water, you form your CO3 2-. That CO3 2- can react with your acid. That acid is your titrant. Ito yung ating standard HCl, as you can recall. Then the carbonate will form your bicarbonate ion. Then your bicarbonate ion, upon titration, will form your carbon dioxide and water. Na sometimes can be also in the form of carbonic acid. Okay? So these are the possible composition of your carbonate mixture. So pwedeng solo lang na sodium hydroxide, pwedeng pure sodium carbonate or pure sodium bicarbonate. Or pwedeng mixture ni sodium carbonate and sodium hydroxide and sodium carbonate and sodium bicarbonate. Okay? And yung mixture of sodium hydroxide and sodium bicarbonate is not stable because of the following reaction. So dito, your hydroxide can act as a base and your bicarbonate ion can act as an acid, forming your carbonate ion. Okay? So pag nagtatitrate tayo, hindi natin alam kung sino yung nag-react with OH minus, si bicarba or si H3O plus. Okay? So that's why the mixture of NaOH and sodium bicarbonate is unstable. So then, as we titrate the carbonate ions or the carbonate mixture, syempre, we will start with the pH that is high kasi nga basic yung ating component. Then as we add our titrant in the form of HCl, you form your carbonate to bicarb and your bicarb to carbonic acid. Okay? And the transition of colors are indicated by the added indicator. So dito nakita natin yung sa phenolphthalein, dito naman yung sa bromcresol green. Okay? Then kapag naman bicarb lang, syempre, hindi natin siya makikita kapag gumamit tayo ng phenolphthalein. Makikita lang natin siya if we make use of the BCG indicator. Okay? Kasi nasa medyo acidic region na tayo kapag bicarbonate to carbonic acid. Then kapag naman hydroxide, ito ay just you can recall from your extra 4A. So your OH minus will be converted to water as you add your H plus in the form of a standard acid. So ngayon, we can make use of the information added, yung volume of the titrant added dun sa ating composition of the carbonate mixture. So dito gagamit tayo ng double flask method wherein the flask 1 will make use of phenolphthalein as the indicator, and then flask 2 will make use of bromcresol green as the indicator. Then we will add a certain amount of acid until you reach the end point of phenolphthalein, which is yung faint pink. And that will be recorded as our VPH, or the volume where you reach the phenolphthalein endpoint. Then in flask 2, you will add certain amount of titrant or yung acid natin until you reach the bromcresol green endpoint, which will be referred as VBCG. Okay, so the qualitative composition of the sample may be deduced from these respective amounts of acids used, referred as VPH and VBCG. So ngayon, let's have a quick explanation on how we make use of this information. So wag muna kayong ma-overwhelm again. So ngayon, let's start with OH minus first. Ayan. So OH minus, para magkaroon ka ng OH minus, dapat, syempre may pinanggalingan yan. Galing yan sa NaOH. Okay? So kapag NaOH lang daw yung laman ng ating flask, and as you add your acid, ibig sabihin, your OH minus, when all OH minus are exhausted and reacted with your titrant added, it will form your H2O indicated by the endpoint as the appearance of the faint pink color. So ngayon, if you use phenolphthalein as the indicator, so you have your VPH or kung ano man yung volume na nakuha nyo for the titration using the phenolphthalein indicator. Then, if you make use of bromcresol green, so there will be a transition of color from blue to yellow-green. And that volume of the titrant added will be referred as VBCG. And the qualitative determination of the composition of the carbonate mixtures is determined when VPH is equal to VBCG. It just means that NaOH lang yung laman ng ating mixture. Okay? So NaOH lang yon. Next naman is, what if we have the carbonate ion? So yung carbonate ion naman natin, galing yan saan? Galing yan sa Na2CO3 or sodium carbonate. So, ang kaya lang kasing i-titrate ni phenolphthalein is yung basic region ng ating pH range. So kung ito ay gagawin nating pH range, ito yung acid range, ito yung basic range. Okay? Tapos ito yung sa bandang neutral. And as you can see, ito lang yung kayang i-titrate ni pH. At ang kayang i-titrate ni BCG is itong buo. Okay? So, when we go back to sodium carbonate, So magkakaroon tayo ng intense pink color to faint pink color when all carbonate ions are converted to its bicarbonate component. Ayan. So dyan natitigil yung ating titration using phenolphthalein and phenolphthalein as indicator. So we will record that as VPH. Ayan. Then, sa second flask mo, gumamit tayo ng bromcresol green. Then sa bromcresol green natin, originally, what we have is carbonate ion pa rin. Tama? Then, as you add your standard acid, it will convert all your carbonate ions to bicarbonate ion. Then, again, as you continuously add your titrant, yung H plus natin, pag ina-add na natin yan, there will come a point that you will reach the bromcresol green endpoint, which is yung yellow-green color natin. And that yellow-green color is indicated by the endpoint of the titration using bromcresol green. So ngayon, if the relationship of the volume of VPH and VBCG is as shown here, VPH is equal to half VBCG, ibig sabihin, sodium carbonate yung meron tayo dun sa sample natin. Kasi equal parts ang ginamit nating acid para ma-convert ang carbonate to bicarb and equal part yung ginamit nating acid para ma-convert si bicarb to carbonic acid. So kung ito ay X amount, so X amount din ito, so 2X yung ating VBCG. Tapos kanina, we established that when all carbonate ions are converted to bicarb, dapat X din yun, di ba? So yung X naman ay yung sa VPH. Kaya dapat ang relationship natin is if VPH is equal to half VBCG, which just means that the composition of the mixture is just carbonate ion or sodium carbonate. Okay? So ngayon, what if magkasama ngayon si OH minus tsaka si bicarb? Si OH minus tsaka si carbonate ion. Ayan. So ganoon lang ulit. So meron tayong OH minus, then meron tayong carbonate ion. So kapag gumamit tayo ng phenolphthalein endpoint or phenolphthalein indicator, so lahat ng H plus natin, gagamitin yan para ma-convert si OH to water. So there is a certain amount of H plus that will be used. Then, additionally, there is a certain amount of H plus that will be used to convert carbonate to bicarbonate ion. So, kapag all of these are converted to water and bicarb respectively using your standard acid, that will reach your endpoint. Doon pa lang natin makikita si faint pink. Okay? Next naman is, what if we make use of the bromcresol green lang? Okay. So sa bromcresol green, ayan. So as you can see here, si bromcresol green kaya niyang i-neutralize from, not neutralize, kaya niyang i-react yung nasa basic tsaka acidic region ng ating mixture. So if lahat ng OH ay napunta na sa H2O, so one component yon. Then kapag lahat ng carbonate ay napunta na sa bicarb, then lahat ng bicarb ay na-convert na sa carbonic acid, then that will signify the endpoint of the endpoint of bromcresol green titration. Okay? Tapos as you can see here, parang mas marami yung basic component kaysa sa acidic component. So you can see, mas maraming na-titrate na component sa basic region kaysa sa acidic region. 'Di ba? So kapag mas marami yung sa basic region, ang relationship natin is VPH. Kapag ang VPH is greater than half of VBCG, it just means that meron kang carbonate and meron kang additional component na nagpapa-add sa basicity. So, ang nagpapa-add sa basicity ay either OH minus lang or bicarb. Doon ka lang pipili doon sa additional component na yon. Kapag OH minus, it adds to the basicity. Kapag bicarb naman, it adds to the acidity. So since mas mataas yung VPH, mas marami na sa basic component, so malamang OH minus yung merong kasama si sodium carbonate. So ang ating sample, most probably, by means of qualitative determination of the components, malamang NaOH at saka sodium carbonate yun. Okay? So, ganito rin sa ating another mixture. So, what if ang mixture natin ay sodium carbonate tsaka sodium bicarb? Okay. So, balik tayo dun sa ating base. So, ngayon gagamit tayo ng phenolphthalein. Ayan. So, sa phenolphthalein natin, magkakaroon lang tayo ng endpoint when carbonate ions are completely converted to its bicarbonate counterpart. So, kapag lahat ng carbonate ay naging bicarb na, it will signify your faint pink color. So, that ends your titration using the phenolphthalein indicator. Whereas, when we make use of the bromcrystal green indicator, ayan. So, itatitrate niya lahat ng carbonate to bicarb from the carbonate ion, then lahat ng bicarb to carbonic acid. Additionally, yung mga bicarb na present from the sodium bicarbonate will be titrated using the standard acid until all bicarb ions are converted to carbonic acid. And kapag na-kompleto itong dalawang ito, dun pa lang natin makikita experimentally si yellow-green endpoint. Okay? Then as you can see here, parang mas marami yung base acidic component kesa dun sa basic component. So again, pag mas marami yung acidic component, malamang ang kasama ni sodium carbonate is si sodium bicarb. So if the volume relationship is VPH is less than half of the VBCG, hence the composition of our carbonate mixture must have been sodium carbonate and sodium bicarbonate. Okay? Tapos kapag naman sa bicarb naman, so as you can see here, wala tayong basic component that can be converted using the phenolphthalein endpoint. That's why sa phenolphthalein natin, kapag bicarb lang ang laman, 0 yan. Ibig sabihin, most likely colorless ang magiging color nan. Okay? So pag nag-add tayo ng indicator at bicarbonate lang ang laman, naglagay tayo ng phenolphthalein indicator, most probably magiging colorless yan kasi acidic yung ating nature of the sample. Next, on another flask, if we make use of the bromcrystal green indicator, all the bicarbonate ions will be converted to carbonic acid when enough standard acid was used to fully exhaust all the bicarbonate ions. So, dito pa lang natin makikita si yellow-green kapag lahat na ng bicarb ay na-convert to carbonic acid. So, if the volume relationship is VPH is equal to 0 and VBCG is greater than 0, ibig sabihin, we are sure that the component present in our carbonate mixture is only sodium bicarbonate. Okay? So these are the volume relationships as you do your preliminary determination of the composition of your carbonate mixture. So, importanteng sa ulo natin, yung mga volume relationship. Actually, kahit din yung sa ulo. Basta you can deduce the meaning behind these volume relationships, okay na kayo, kahit din siya sa ulo. Okay? Pero if you want to learn it by memorizing, okay lang din. Pero much better if you can deduce it on your own without even memorizing the volume relationship. As long as alam mo na kapag mas marami yung volume na nagamit sa basic kaysa sa half nung acidic na BCG, ibig sabihin, mas marami kang basic component. Pag mas marami kang basic component, most likely we have OH and sodium carbonate. Pero kapag equal naman yung half ng dalawa, might as well NaOH lang yung laman nun. Wala siyang sodium carbonate. Okay? So next naman natin ay, ayan. So yung pinakita nating volume relationships, it works kapag 2 flask. Doon sa 1 flask naman, I think you can deduce it on your own. Kasi for example, sa sodium carbonate, pag Na2, CO3 lang ang laman nito, So, una, gagamit ka ang indicator mo laging una ay phenolphthalein. Sa phenolphthalein kasi, you can deduce kung ano yung amount na basic component meron yung ating mixture. So, magfe-faint pink yan kapag lahat ng carbonate ay naging bicarb na. So, ito yung faint pink natin. So, pag nag-faint pink na, dun ka mag-a-add ng second indicator na bromcasol green. Then, yung bromcasol green natin is mag-yellow green kapag all bicarb ions ay naging carbonate ions na. So, mag-yellow green yan. So, kung naman yung volume na gamit mo sa VBCG, VPH rather, dapat ganoon yung volume na nagamit mo kay VBCG. That's why here, pag one flask method, VPH is equal to VBCG. Okay? So kapag naman one flask tapos you have sodium carbonate and NaOH, syempre, ganoon lang din yung implication nun. So i-clear natin to. Ayan. So suppose you have these components, no? At single flask lang. So you have one flask. Ang laman ng flask mo daw ay CO3 2-, tsaka OH-. So as you add your phenolphthalein, so ito yung nadidetect natin sa phenolphthalein. Tsaka water. Yan. So kapag ito ay na-reach na, you have your VPH. Then HCO3, so yung VPH natin, mag-faint pink na yan kapag lahat ito ay na-convert na to this one. Tapos, hindi pa tapos yung titration natin. You will add ito ay indicator 1 or indicator pH. Next is, as you add your second indicator na BCG, all bicarbonate will be converted to carbonic acid. So that serves as your VBCG. So, kung XML yung nagamit mo dito, dapat XML din dito, di ba? Kasi we have established that equal amounts of H plus ang nagagamit natin sa conversion ng H plus to conversion ng carbonate to bicarb and bicarbonate to carbonic acid. Tapos ngayon, gamit tayo ng arbitrary variable. For example, we make this Y. Yan. So, ibig sabihin, sa phenolphthalein natin, X plus Y yung nagamit natin na VPH. Whereas sa VBCG, ang nagamit lang natin is X. So dito, since mas malaki si VPH kesa kay VBCG, alam dapat natin na carbonate and sodium hydroxide ang meron. Okay? Next naman, if you have sodium carbonate tsaka sodium bicarb, so clear natin to. So if you have these two, so again, you have one flask. Ang laman niya ay carbonate ion tsaka bicarb ion. So para mas madali, ilatag natin sila as if pH dependent yung ating ladder. Ayan, HCO3-. Okay. So as we add our first indicator na phenolphthalein, it will convert all carbonate ion to bicarb ion. And that will serve as your VPH. So, pag na-convert na tong part na to, yun na yung, faint pink endpoint. Next ay, pag nag-faint pink na siya, we will add the second indicator na BCG. So, it will convert all bicarbonate to carbonic acid. And the bicarbonate na hiwalay na from sodium bicarbonate, it will convert to carbonic acid. And this will serve as your VBCG. Okay, so as we have established earlier, kung ano yung amount na nagamit dito sa carbonate to bicarb, let's make that as X. Then yung bicarb na dito sa ladder na to, dito lang sa ladder na to, yung X na yon dapat equal dun sa amount na bicarb to carbonic acid. Pero not necessarily parehas dito kasi most likely ibang amount yon based dun sa amount ng sodium bicarbonate na present initially dun sa ating mixture. So let's refer this kunwari as Z. Yan. So ang VPH natin ay equal lamang kay X at ang VBCG natin ay equal sa X plus Z. So take note that since mas malaki ang BCG kaysa kay pH, ayan. So, yun yung ating establishment of the volume relationship kapag one flask. So, meaning to say, sodium carbonate at sodium bicarb lang yung meron dun sa ating sample. Okay? Next naman is NaOH. Sa NaOH, i-erase natin to. Sa NaOH natin, we have established that we will make use first of the phenolphthalein indicator. So, kung meron tayong one flask at OH lang ang laman nito, yan. So, ang ating first indicator is phenolphthalein. So, all OH will be converted to water. So, that serves as your VPH. So, ito na yung endpoint natin. So, nag-endpoint na tayo. Water na lang to. Pag nag-add tayo ng second indicator na VCG, ayan. So, wala na kayo magagamit na BCG indicator. Bakit? Kasi water na lang yung laman natin. Okay? So, ang magiging kulay nito ay color blue. Tapos, upon addition of very, very small amount of titrate, bakit siya blue? Kasi nasa pH 7 tayo ngayon. Kasi neutral to eh. As we can recall dun sa ating... Asa na yun? Yung endpoint natin kanina. Yan. At pH 7, ang bronchosol green ay color blue. Yan. Pero pag nag-add tayo ng super minute amount of standard na titrant, magiging color yellow agad yon. So that indicates na, wala palang laman yon na anything acidic or basic that needs to be titrated with standard acid. Okay? So yun yung implication nun. From blue, magiging sharp turn of yellow yon. Okay? So, insignificant yung amount ng drop na yon, kaya BCG is equal to 0. Kasi yung VPH mo equal to a certain value X. Yan. So, ganun din kay bicarb. So, sa bicarb naman, suppose ito ay HCO3 lang ang laman. Pag naglagay ka ng phenolphthalein indicator, ang magiging kulay niyan ay colorless agad. So, hindi siya magiging pink kasi acidic siya. So, ngayon, alam mo na dapat na VPH ay equal to 0. Then, afterwards, when you add your second indicator na BCG, magiging color blue yan. Then, as you add your H plus until you reach your carbonic acid, at nakuha mo na yung yellow-green endpoint, meron ka ng BCG equal to X. So, kapag 0 ang VPH at may value ang BCG, ayan. Meaning to say, sodium bicarbonate yung meron tayo. Okay? So, here's the calculation for the single component only. So, madali lang to. So, saan galing yung NV natin? Ang NV natin ay galing sa equivalence yan. Equivalence of NaOH equals equivalence of NaOH multiplied to equivalent weight ni NaOH. So, yun ay, ano bang equivalent weight? So, yun ay gram per equivalent times dilution factor over volume of sample in ml. So, volume, ml yun, times 100. So, magka-cancel to. So, you have grams in ml times 100. You have percent weight per volume na as answer. So, ang crucial lang dito is, ano bang gagamit nating volume? Phenolphthalein ba or BCG? So, dapat alam natin yung mga part na yon. Okay? Since the NaOH naman is working on the both side, on the basic region only, and inuuna natin si phenolphthalein. So, most likely, phenolphthalein yung volume na gagamitin natin. Then si BCG naman, since it covers both the acidic and the basic region, so si BCG na. Likewise for bicarbonate. Okay. So in our class, we have made some modifications. Ayan. Sa flask 1, if ang ating mixture ay sodium hydroxide and sodium carbonate, yung flask 1 natin, ang ginamit natin ay bromcresol green lang. Then we add standard HCl, then we boil and cool to remove carbon dioxide. Then we continue titration until we reach the endpoint. So since we have OH minus and carbonate ion, yan. So kaya nga i-cover yung total basic strength natin. Okay? Tapos magiging H2CO3 ito. So ito yung, sorry. Walang undo. So ito yung kayang i-cover ni BCG. Okay, itong buong to. So that's the total basic strength. Then for flask 2, what happens here is we have OH minus and CO3 2 minus. Then we add certain amount of 10% BaCl2 to precipitate out carbonate ion. So pag nag-add tayo ng BaCl2, so yung Ba2 plus na yon, so walang effect yun kay OH minus. So meron ka pa rin OH minus doon. Pero may effect siya kay carbonate. So yung carbonate natin ay magiging BaCO3. BaCO3. Okay? Tapos, kapag lahat ng carbonate ay natanggal na natin as precipitate, so we can now continue titration to determine the amount of OH. H2O. So, ito ay VPH. Okay? So, sa VPH natin, we can determine the amount of NaOH present. So, dito, we can determine the equivalence of NaOH, whereas in the flask 1, it's the total basic strength equal to the equivalence of NaOH plus the equivalence of sodium carbonate. Okay? So ngayon, para lang malaman natin yung composition natin. So once we have established that the TBS from the flask 1 is equal to the equivalence of NaOH and equivalence of Na2CO3, and experimentally, we can determine that by getting NV. Di ba pag equivalence ng liquid is just NV? Okay, normality ng acid multiplied to the volume using the BCG endpoint or the VBCG. Then in flask 2, we separate carbonate ion as barium carbonate solid. So it is as precipitate. Then yung ions na natira is yung OH minus will be titrated as H plus forming your water. So makukuha natin yung equivalence ni OH minus as NV naman ng phenolphthalein. Then mathematically, we can just get the EQ of Na2CO3 by getting the difference of TBS and the equivalence of NaOH from flask 2. So we get the EQ ng Na2CO3. Okay? So ngayon, meron na tayong EQ na value na dalawa. So we can calculate for the percent composition of sodium carbonate and sodium hydroxide by using this equation. Okay? So next naman is, what if we have a mixture of sodium carbonate and sodium bicarbonate? So same yung gagawin natin for flask 1. We can get the total basic strength in flask 1. Kasi meron tayo ditong CO3 2 minus tsaka bicarb. So yung CO3 natin, makakonvert yan to bicarb. Yung bicarb makakonvert to carbonic acid. Ito ay makakonvert to carbonic acid. H2CO3. At itong buong to, ito yung ating BCG. VBCG. Okay? And this corresponds to the total basic strength of the mixture. Then yung flask 2 natin, gagawa tayo ng modification na we transfer certain amount of sample in the flask. Then you will add NaOH to convert bicarb to carbonate. Then after converting all bicarb to carbonate, you will add barium chloride solution to convert all carbonate to barium carbonate. So parang ginawa natin yung kanina, pinaprecipitate out natin lahat ng carbonate. Then you will add certain amount of standard acid until faint pink color appears. Okay. Ano nangyayari dito? So dito meron tayong, originally we have CO3. Ay, hindi, sige, dito lang sa kabilang side. We have CO3, 2 minus, then we have bicarb. Okay. So dito, ang first step is naglagay ng OH minus. So yung OH minus natin, it converts your HCO3 to carbonate. So OH minus. So yung HCO3 natin will act as an acid, OH minus will act as a base. So magkakaroon tayo ng H2O plus CO3 2 minus. Ito yung nangyari dito. Tapos sa CO3 2 minus, ganun pa din. Walang effect sa kanya yung addition of OH minus. Next is, nag-add tayo ng barium chloride. So, syempre, meron tayong, since excess tong ating NaOH, meron yang OH minus na in excess. Ito ay gawin natin total. Okay? Next ay, nag-add tayo ng barium chloride. So, we add Ba2 plus. So that all carbonate ions will be converted to its precipitate form. Ayan. So itong CO3 minus magiging BaCO3 ulit. Tapos wala siyang effect kay OH minus. So meron tayo para tayong OH minus dito na excess. Okay? Tapos actually yung excess natin na OH minus, yan ang itatitrate natin for flask 2. As we add our phenolphthalein, so magiging H2O yan. So ito na yung faint pink endpoint. Okay? So next naman natin is on the third flask. Ito yung may third flask kasi. Ito yung blank titration natin. Sa third flask natin, so ano dito meron tayong excess OH minus. Ito yung tinitrate natin. So equivalence na yung nakuha natin. Okay? So dito sa third flask, ayan. Instead na XML of sample, you will add XML of water. So meron kang water, tapos nag-add ka ng barium chloride solution, Ba2 plus. So water pa rin yan, plus Ba2 plus. Then nag-add ka ng NaOH. So wala pa rin effect yan, H2O lang yan, tsaka Ba2 plus, tsaka OH minus. Basically, same ML yun, di ba? YML, tapos ito YML. So ito yung na-establish nating OH minus na total kanina. Then yung total OH minus natin, ito yung itatitrate natin with standard acid until you reach the phenolphthalein endpoint. Yan. So ngayon, yung difference nito is yung difference ng total tsaka excess that constitutes to the amount of OH minus reacted to convert bicarb to carbonate ion. So essentially, we can determine the amount of equivalence ng NaHCO3. Okay? So ito ay equal sa N ng V ng blank minus V ng sample. Okay? Kasi yung blank natin ito, yung total, then yung sample natin is yung excess lang, natira. Yung hindi mga nag-react with HCO3 minus. Okay? So that's what happened in each flask. So here comes our equation. So makukuha natin yung bicarb equivalence as the difference of the blank minus sample multiplied to normality. Then yung sodium carbonate natin is just TBS minus yung equivalence ng bicarb. Tapos once you have calculated these two, ilagay nyo lang yan sa ating equation. Okay? So again, yung ating NaOH and bicarb mixture is unstable. So ito yung kulay ng before titration for BCG. Then yung endpoint natin na more yellow than green, then overall na kapag kulay yellow na yan. Then doon naman sa ating phenolphthalein, so magsistart yan sa intense pink, tapos ang endpoint natin is yung barely kita mo lang yung pagkakulay pink. So faint pink pa rin. Tapos meron siyang tinge of white kasi meron tayong precipitates na barium carbonate. Okay? So might as well ma-experience yun na nagka-titrate tapos may umiikot na white precipitates. So that's your barium carbonate. Okay, let's have some sample problem. Yeah. So, pause muna. Okay, so here's our first sample problem. Yan, a sample containing permissible combination of NaOH, bicarb, and sodium carbonate was subjected to Winkler method. Exactly 5 ml of sample was obtained and diluted in a 100 ml vol flask. From the diluted sample, a 20 ml sample was titrated, requiring 5 ml of standard 0.0973 normal HCl to reach the BCG endpoint. In a separate flask, another 20 ml portion was transferred where the slight excess of barium chloride was added prior to titration with the same HCl solution, requiring 2.9 ml to reach the phenolphthalein endpoint. Calculate the percentage of the components in percent weight per volume in the sample. Okay, so ngayon, pwede tayong mag-preliminary investigation kung ano ba yung components na meron tayo. Okay? So ngayon, well, we'll check. So dito daw, 20 ml requires daw 5 ml ng BCG. So ang VBCG mo is 5 ml. Tapos, ang next ay same to portion, 20 ml, it requires daw 2.9 ml. So, VPH natin is 2.9 ml. Yan. So, ngayon, i-compare natin yung relationship, volume relationship ng VPH and half VBCG. So, ang half ng VBCG natin is 2.5. Ang VPH natin is 2.9. So, mas malaki ito. Ibig sabihin, mas marami tayong basic component sa mixture. So, pag marami tayong basic component, ang ating component ay most probably NaOH and sodium carbonate. Okay? So, ngayon, i-calculate na natin to. So, dito, gumamit tayo ng, since ito yung laman natin, OH minus, tsaka CO32 minus. Nag-titrate daw tayo, gamit ang H plus, until naging water siya. Ito ay naging bicarb. Tapos yung bicarb natin ay magiging, tatitrate ulit natin until maging carbonic acid. Okay. So sa BCG natin, what we can determine is the total basic strength. So TBS is equal to the equivalence of NaOH plus the equivalence of sodium carbonate. Tapos, experimentally, we can do this as N ng HCl multiplied to volume ng BCG. Kasi ito, matatitrate natin to whole with using BCG. So, ilalagay lang natin to as 0.0973 normal. So, ang volume ng BCG na nagamit for this one is 5 ml. So, 5 ml. So, dapat ito ay in liters. So, 1,000 ml in 1 liter. Okay, so magka-cancel yung ml. So, yung ating normality ay, ano yan, equivalent per liter yan. So, ngayon, pwede natin ito ilagay as equivalent per liter. Ka-cancel yung liter. So, ang TBS natin ay isi-store natin as letter A, equivalent. Okay? So, i-store natin sa calculator as A. Next naman is yung calculation natin for, wait lang, solve na nga natin. So, 0.0973 times 5 divided by 1,000. Ayan. So, ito ay equal to 4.865 times 10 to the 4, negative 4, equivalent. Okay. Next naman, ang ating modified procedure using flask 2. So, OH minus plus CO3 2 minus. Sabi dito, in another flask, naglagay ng barium chloride. So, pag nalagay ng barium dito, nagiging barium carbonate siya. So, wala siyang effect kay OH minus. Then, you will add HCl until you reach the phenolphthalein endpoint. Pag nag-add ng HCl, yan, you reach water as endpoint. BPHI 2.9 ml. So, here, ang nakuha natin ay equivalence ni OH. So, equivalence ni NaOH ay equal sa N ni HCl multiplied to V pH. So, ito ay 0.0973 equivalent per liter multiplied to 2.9 ml. Then, 1,000 ml in 1 liter. Okay. So, isa-store natin to kay letter B. Equivalent. NaOH. Okay? Tapos, ngayon, to calculate for equivalence ng Na2CO3 is just equal to TBS minus equivalence ni NaOH. So, ang TBS natin kanina is A. Ang NaOH natin is B. Nakastore sa calcul nyo. Then, let's store it as letter C, equivalence. So, ang C natin is yung equivalence ni sodium carbonate. Okay? So, to calculate for the percent weight per volume, so, unahin natin si NaOH. So, percent NaOH ay equal to equivalence ni NaOH. Equivalence sa NaOH kanina is na-establish natin as letter B. So, B, equivalence times equivalent weight. So, 39.998 gram per equivalent times dilution factor. So, dito, exactly 5 ml was diluted to 100. So, 100 over 5 ml. Divided by the volume of the sample used, 20 ml. Times 100. So, sagot dito ay store natin kay letter D. Percent weight per volume. Okay? Then, yung percent naman ng percent Na2CO3 ay equal to letter C, equivalence, times yung ating equivalent weight ni sodium carbonate. So, 105.989 grams per 2 equivalent. Bakit 2? Kasi di ba, as you can see, 1 equivalent, 2 equivalent. So it requires 2 moles of each para ma-convert si carbonate to carbonic acid and vice versa. So version 2 dyan, times dilution factor na 100/5 divided by 20 ml times 100. So ito ay store natin as letter E. Percent weight per volume. Okay? So that is how you will solve this problem. So in this case, the answer should have been 1.08% and 1.13% sodium carbonate and NaOH respectively. Okay? So ito yung ating calculation kanina. Okay? So next naman natin ay ito. Okay, so an anhydrous sodium carbonate is suspected to be contaminated with sodium bicarb. To verify the suspicion, double flask titration method was used to determine the purity of the solid. So exactly 1.2370 gram of the sample was made up to 250 ml of solution. Then 25 ml portion of the solution was treated with a known amount of NaOH and excess barium chloride, and that required 11.20 ml of standard 0.1 normal HCl with phenolphthalein as indicator, and 23 ml of the same titrant to reach the bromcresol green endpoint on another flask. So 2 flask method ito. Then a blank titration was done for third flask where same 25 ml of water was added with same amount of barium chloride and NaOH, and 11.8 of the same acid was used for phenolphthalein endpoint. If the sample is the sample impure? If yes, calculate the percentage by weight ng sodium bicarb and sodium carbonate. Okay, so dito nabigay na kung ano yung composition ng ating mixture. So ito ay possibly sodium carbonate with a possible contamination of sodium bicarb. Okay. So ngayon, alamin mo natin yung sa flask 1. Sa flask 1 natin, ang bromcresol green, gumamit siya ng ilan nga? 23 ml. Yan. Tapos, sa flask 2 naman, gumamit siya ng phenolphthalein na ilan? 11.8 ml. So ngayon, let's check for volume relationship, VPH and half VBCG. So ang VPH natin is 11.8. Ang half VBCG natin is 11.5. Ayan. So as you can see, mas malaki ng 0.3 yung phenolphthalein kaysa dun sa half VBCG. So it is safe to say that impure yung ating sample. Impure. Na merong contamination ng bicarb. Okay? So ngayon naman, ay aalamin natin if ano ba yung composition ng sample natin. Okay. Let's delete this. So yung TBS natin, yan ay equal to NHCl VBCG. Na equal din yan sa equivalence ni bicarb and equivalence ni carbonate. Okay? So ang N natin is 0.1. Ang volume na nagamit natin is 23. Ay, wait lang. Mali pala. Sorry. 11.2 pala ito. 11.2. So, ito ay, kaya pala medyo confusing kanina. VPH mo ay 11.2. Half VBCG mo is 22, 11.5. So, mas malaki si half VBCG. So, talaga dapat meron siyang bicarb and Na2CO3. Kaya na medyo nalito ako. Gawa ng, bakit mas malaki yung VPH pero bicarb yung kasama niya, hindi NaOH. Ayan, 11.2 pala. Alright? So, ang VBCG natin ay 23. Tama ba? 23. 23 ml. Then, 1,000 ml, 1 liter. And lagyan natin yan as letter A, equivalence. Okay? Tapos, sa second flask, ano nangyari kay second flask? Gumamit daw siya ng 11.2 na phenolphthalein naman. Pero, meron tayong treatment ng NaOH and barium chloride. So, yung ating HCO3 minus tsaka CO3 2 minus, as you add your NaOH, it converts your bicarb to CO3. And CO3. Then, meron kang OH minus na excess. Ito yung total. Okay? Tapos, naglagay ka ng barium chloride. So, lahat ng carbonate natin ay magiging barium carbonate. Tapos, nandiyan pa rin yung OH natin na excess. Then, yung OH nating excess, yan na yung matatitrate natin with VPH. Okay. So, dito, sa flask 3 naman, ganoon din yung approach natin, pero water lang yung laman. So, water with OH minus total. So, OH minus lang yon. Tapos nag-add pa ng barium chloride. So, may barium 2 plus ka lang doon. Then, itatitrate mo na siya with standard acid. You get water. So, you have your VPH as well for OH total. Okay? So, using the information from flasks 2 and 3, we get the equivalence of bicarb. So, it's just equal to NaHCl multiply to volume ng VPH ng blank minus volume ng sample. So, ito ay 0.1 times volume ng blank is 11.8 minus 11.2 ml. Siyempre, yung ml natin ay convert natin to liter. Okay. So, we will have this recorded as B in our calculators. Then, to calculate for equivalence na Na2CO3 is just equal to A minus B na nakastore kay calcu nyo. So, let's have this as letter C. Okay? So, to calculate for the percent by weight, so weight per weight, ng sodium carbonate, so it's just equal to C times equivalent weight ni sodium carbonate, so 105. So ito ay formula weight divided by the number of equivalents. So 105 gram per 2 equivalent. Okay? Tapos, may DF ba tayo dito? So 25 ml ay from 250. So 250 divided by 25 over 1.2373. 2370 gram. So ito ay magiging gram per gram. So tama. Percent weight by weight nga. Times 100. Okay? So ang sagot natin dito is letter D. Percent weight per weight. Kung ano man yung value na yan, store natin kay CalQ and yung isasagot nyo as percent Na2CO3. Then yung percent sodium bicarbonate naman, pwede nyo siyang gawin lang na 100 minus D. Kasi impure sample daw siya. So, you need to say, ano siya, sodium carbonate plus bicarb lang. Okay? So, in that case, so dapat ang naging sagot natin ay 96.0% sodium carbonate lang yung laman ng ating sample at 4.07% na impurities na sodium bicarb, making it an impure anhydrous sodium carbonate. Okay? So ito yung ating naging calculation for that. All right. So I think this ends the presentation for double indicator titration. So if you have any question, you may raise it through our channels. So ang channel natin ay Google Space. Okay? So for that, we will end the discussion now and thank you for listening.